What if NASA had colonized Mars in the 1970s? It sounds insane, but real engineers actually drafted serious mission plans. This idea wasn't fantasy. NASA concepts once aimed to extend Apollo beyond the moon, all the way to Mars. The journey begins in the 1940s with Wernher von Braun, one of history's most influential rocket scientists. Von Braun became famous for designing rockets in Germany, long before America ever reached space. During World War II, he helped build the V-2 rocket, the first long-range guided ballistic missile ever created. The V-2 proved rockets could reach extreme altitudes, setting the foundation for future space exploration technology. After the war, the United States recruited German scientists through Operation Paperclip, including von Braun. Von Braun eventually moved to NASA and became director of the Marshall Space Flight Center in Alabama. There, he helped design the Saturn V, the powerful rocket that carried astronauts to the moon. But while working on Apollo, von Braun also imagined an even bigger mission: humans traveling to Mars. He created a detailed concept called Project Mars, outlining how a Mars expedition could work using known technology. Project Mars included story elements, but also serious calculations, formulas, and engineering logic for real interplanetary travel. His vision relied on building massive space stations in low Earth orbit before launching any Mars expedition. These stations would rotate slowly to create artificial gravity, allowing crews to live comfortably in orbit for months. Von Braun also proposed an orbital construction yard, where spacecraft parts would be assembled like a shipyard in space. Instead of launching one giant Mars rocket, multiple launches would deliver components to orbit for assembly. He designed a reusable ferry rocket to carry supplies and materials from Earth to the orbital construction site. This ferry rocket would make frequent trips, like a space cargo vehicle supporting continuous orbital building operations. Once assembled, the Mars fleet would include transport ships, cargo haulers, and landing vehicles built in orbit. Von Braun imagined the fleet forming around 1,000 miles above Earth, far beyond the atmosphere's drag. The crew would live inside large spherical compartments designed for life support, storage, and long-duration travel. Each ship would use clusters of liquid-fueled engines, supported by huge fuel tanks along the vehicle's main body. Von Braun favored hypergolic propellants, chemicals that ignite automatically when mixed, making space ignition reliable. Hypergolic fuels are still used today because they start instantly and work well in the vacuum of space. Even modern SpaceX Dragon thrusters use hypergolic engines for precise maneuvering in orbit. Once ready, the fleet would burn engines to escape Earth's gravity and enter a direct transfer path toward Mars. This launch would happen during a transfer window when Earth and Mars align for the shortest route. Von Braun estimated the travel time would be about 260 days, around 8.5 months in deep space. As the fleet approached Mars, it would rotate and burn engines again to slow down for orbital insertion. The target orbit was around 620 miles above Mars, allowing safe positioning and preparation for landing operations. From orbit, Mars landing vehicles would separate from the main ships and begin descent toward the surface. Von Braun's landers were designed as glider-style craft meant to fly through the Martian atmosphere. After touchdown, the lander would be repositioned vertically, becoming part of the base structure for the first colony. Astronauts would unload equipment, habitats, and supplies, establishing the first human outpost on Mars. After the mission, the vertical ascent rockets would launch from Mars and rendezvous with the transport fleet waiting in orbit. With the crew safely back on board, the fleet would ignite engines again and begin the long return trajectory toward Earth. On paper, the entire mission sounded simple, especially to engineers living in the optimistic post-war era. But in the 1940s, humanity barely understood Mars, and many assumptions were dangerously incorrect. Von Braun believed Mars might contain canals, lakes, vegetation, and maybe even intelligent alien civilizations. Reality turned out far harsher, with Mars having almost no atmosphere, less than 1% of Earth's density. That thin air meant von Braun's glider-lander concept would fail because it could never generate enough lift. By the 1950s, Mars mission concepts evolved as new technologies entered the spotlight, and especially nuclear energy. This was the atomic age when people believed nuclear power could provide unlimited energy for the future. Rocket scientists quickly realized nuclear power could transform deep space travel, making long missions more feasible. One key figure was Ernst Stuhlinger, a scientist who worked closely with von Braun on advanced propulsion concepts. Stuhlinger redesigned Project Mars for the atomic era, replacing chemical rockets with nuclear electric spacecraft. His nuclear ship plan became famous and was even presented on American television in the late 1950s. Walt Disney aired a program called Mars and Beyond, showing futuristic animations and serious engineering concepts. The show featured von Braun and Stuhlinger explaining how humans could realistically reach Mars using nuclear technology. In their design, chemical rockets still launched parts into orbit where the giant nuclear spacecraft would be assembled. The completed ship would stretch hundreds of feet wide and carry crew quarters, cargo storage, and a dedicated lander. At the bottom sat a nuclear reactor producing heat through fission, splitting atoms to generate continuous power. That heat boiled a special oil into steam, driving turbines that produced electricity for the entire spacecraft. The steam would then cool in a large condenser ring, recycling endlessly in a closed-loop power system. The spacecraft's main engine used electricity to ionize cesium atoms and accelerate them outward as exhaust. This ion propulsion created low thrust but extremely high efficiency, allowing constant acceleration over months. Modern satellites and deep space probes still use similar ion thrusters, proving Stuhlinger was decades ahead. The crew habitat sat near the top, shielded from radiation, with room for up to 20 passengers. Attached near the front was a Mars lander, designed to detach once the main ship entered Martian orbit. Instead of a glider, this lander used a parachute system, which was a major improvement over earlier concepts. However, Mars air was still too thin, so rockets would fire at the final moment for a controlled touchdown. This parachute plus rocket landing method is basically the same approach used in modern Mars landing missions. After surface exploration, astronauts would return to the lander and launch an ascent module back to orbit. The nuclear electric transit time was extremely long, around 13 months, exposing crews to radiation and microgravity. By the 1960s, NASA achieved huge success with Mercury, Gemini, and Apollo, pushing human spaceflight forward fast. With Saturn V nearly complete, NASA began planning beyond the moon, aiming for a human Mars mission in the 1980s. In 1968, Boeing proposed a more powerful concept using nuclear thermal rockets instead of slow ion propulsion. Nuclear thermal engines heat liquid hydrogen directly through a reactor core, producing strong thrust efficiently. This design offered a faster Mars transfer, potentially reaching Mars orbit in under 200 days. The spacecraft would be assembled in orbit using multiple Saturn V launches, carrying enormous propulsion modules. It included crew modules, a mission habitat cylinder, a Mars excursion lander, and an Earth re-entry capsule. The plan required a massive departure burn, a Mars insertion burn, and finally a return burn back home. After Mars exploration, astronauts would launch back to orbit, dock with the main ship, and prepare for Earth return. Despite being possible, Mars missions died due to politics, Vietnam, shrinking budgets, and the Space Shuttle decision.